This is a help video for part 3 of the Unit 1 consolidation task. This is an extension to the calculation section. I would recommend that you look at this video if you're really aiming for a strong A or B grade. Then you definitely want to be making sure that you get the hang of this type of calculation. Otherwise, it's probably not going to be the top of your priority list, and you might want to focus on doing some other revision, perhaps from BBC Bite Size or Scholar. So when it comes to calculations from balanced equations, we're going to look at two types. First one, we're going to look at the ones involving masses, and then we're going to look at the titration calculations. In this video, I'm going to do question 1A, and then I'm going to leave you to do B and C as practice, and then I'm going to do the whole of question 2, but you might want to try that first, and then the practice that you've got for question 2 is just going to be looking at some past paper questions. So let's start with question 1A. 1A says, calculate the mass of hydrogen required to react with 56 grams of nitrogen. So the first thing to recognise, and I haven't actually put any marks beside these, but in an exam, this would be a 3-mark question. So you can recognise this type of question because it will talk about calculating something, it will give you a balanced equation, and it will be a 3-mark calculation. Not all 3-mark calculations are of this type, but most of them, quite often they are. So when we're doing our balanced equation calculations, we need to remember that the balanced equation gives us information about the quantity of each different reactant required to make a certain quantity of product, and that information is given by the numbers in front, or if there's no number, it's a 1. So that information we call the mole ratio. Okay? And in this equation here, in this example for 1A, we would say, well, there's no number in front of nitrogen, so we would say the ratio for that is 1. For hydrogen, we would say it's 3. And for NH3, we would say it is 2. So N2, H2, and NH3. And what that means is 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of NH3. So that's just getting a little bit of an understanding of what the information in the balanced equation is telling you. You don't need to write this out as a first step, so that's just a little bit of background. Okay, so what is the first step? What would I like you to do if you were doing this question in an exam? Well, the first thing I would do would be to figure out what substances in the equation it's talking about and what information I'm given. So the question says calculate the mass of hydrogen. So hydrogen you should recognise is this symbol here, H2, and it says calculate the mass of hydrogen required to react with 56 grams. So I would underline any numbers I'm given, and the 56 grams is of nitrogen. So that's this one here. So I'm not going to write down that that's step 1, but that's the preparation work that I need to do. I need to figure out what substances in the equation is it talking about and what information is it giving me in the question. Okay, so that's all good so far. Now, something that you need to remember is that because balanced equations are all about the mole ratio, when you're doing these calculations, you need to work through into moles. That's the way I've taught you. There are other ways, but I think this is the one of the best ways to do these types of calculations. So, what you're going to do, once you figured out each of the substances that it's talking about in the question, I would begin a data column for each one, and I would write down the information that you're given about it, what you're asked to calculate, and you're going to always use the symbol N because you're always going to have to work out the number of moles, but you won't know that for either of them. So let's start with nitrogen. Number of moles we don't know, but we will have to work that out. What information are we given about nitrogen? Well, we're given 56 grams. We've done a little bit of work already on reminding ourselves what grams is a measure of. Grams is a measure of mass. So the mass is 56 grams. And if we've got mass, then that tells us that we're probably going to need to use N equals M over GFM. Okay. Now, again, in the exam, I would always check that in the front page of your data book. N equals M over GFM. Okay, and to use that equation, we need to also work out the GFM. Now remember, we can always work out the GFM as long as we know the name or the formula of the substance. So nitrogen, we've got the formula N2. So we're going to do 2 times the relative atomic mass of nitrogen, which is 14. So that's going to give us a GFM of 28 grams per mole. Okay. For hydrogen, we don't know the number of moles. It's asking us to calculate the mass though, so I'm going to put a little m here. We don't know that either at the moment. The GFM is something that we can work out though. So our GFM for hydrogen, 2 times 1, which is the relative atomic mass of hydrogen, is 2 grams per mole. Okay, so once we've done this groundwork, if you like, this preparation, we've looked at the question and we've written out the information that we can for each of the substances in the equation. Once we've done that, then step 1 is going to be using the information that we've got to calculate the number of moles of the substance we have most information for. So we've got 2 blanks for hydrogen, we've got 2 question marks here. We can't calculate the number of moles of that, but we can calculate the number of moles of nitrogen. So step 1 is the moles of what you've got most information for. Okay, so I'm going to do N equals M over GFM. So that's going to be for nitrogen. So in this case it's nitrogen that I've got the most information about. M is going to be 56, the GFM is 28. So N is M over GFM, which is going to be 56 divided by 28, which equals 2. So that is 2 moles of nitrogen. Okay. So I know I've got 2 moles of nitrogen, and I'm going to work out what mass of hydrogen would be required to react with that. Okay, so my step 2 is going to be using the mole ratio. So step 2, I like to write this out in full. So I'm looking at my substances in the equation, nitrogen and hydrogen, N2 to H2. So it's the mole ratio for N2 to H2 that I'm looking at. And there's no number in front of nitrogen, so that's a 1, and there are 3 H2. So it's a 1 to 3 ratio. Now, I'm hoping that you should be reasonably confident with ratios from maths in order to be able to do these questions. So if it's a 1 to 3 ratio, but I have 2 moles of nitrogen, to get the number of moles of hydrogen, you just need to think, well, what do I need to do to get from here to here? I need to times by 3. So I'm going to do 2 times 3, which gives me 6 moles of hydrogen. So now that I have the number of moles of hydrogen, I can put that into my data column here. So my N is 6 moles of hydrogen. And now I just need to work out the mass. Now, I know it's a little bit messy, but I've done my triangle over here. So my final step is going to be to calculate the mass of the other thing in the equation, of the other substance. Now, either rearranging the equation yourself or just using the triangle, M is on top, so if I cover up M, N and GFM are beside each other, so I need to do M equals N times GFM. And remember, this is for hydrogen now, so that's the other substance, the one that I didn't have information for at the start. The other substance was hydrogen. M equals N times GFM. From the mole ratio, I knew that the number of moles was 6 moles. I'd already worked out the GFM, that's 2 grams per mole. So 6 times 2, and that's going to give me 12 grams of hydrogen. And I would just double underline my final answer here. Okay, so you should be able to complete question 1B and C in a very similar way, and then I've given you a little link to a past paper for you to do a little bit more practice of this type of question based on a past paper, because obviously it's easy enough sometimes to do it when you've just seen an example, but it's recognising what you need to do in a past paper where it's not exactly the same format. Okay, so I'm just going to talk through question 2 now. So question 2, I would like you to attempt yourself first before you hear me going through the answers, so that's quite important. So if you want to, you can pause the video now and have a go at question 2. Okay, so I'm hoping you've made an attempt at question 2, and I'm just going to run through the answers really. So question 2 is a titration calculation, and it says, in an investigation to find the concentration of sodium hydroxide in a bottle which hadn't been labelled, a student carried out 3 titrations. Each time, 25 centimetre cubed samples of the sodium hydroxide were pipetted into a conical flask and titrated with 0.1 mole per litre sulphuric acid. Now, if this were me in an exam, as I'm going through this, I'm going to be underlining the numbers that I'm given, just to make those clear in my head. The following results were obtained. So I've got titration, 1, 2, 3, and then I've got the volume of 0.1 mole per litre sulphuric acid used, and the volume is measured in centimetres cubed. I've got 3 different numbers here. Okay, so it says one of the titrations can be described as a rough titration. What is meant by rough when doing a titration? So hopefully you remember this from the experiment that we did. The rough one is just the approximate one, so I would just say approximate for what is meant by rough. Okay, something like that. And which titration is the rough titration? Well, generally when we're doing the rough titration, we're just trying to get, like I say, an approximate indication of how much of the titrant, the thing that in the burette that we need to add to get the reaction to its end point. So quite often we just add the reactant in quite quickly, and then we end up what we call overshooting the end point a bit. We end up adding a bit too much. So generally the rough one is the first one that we do, and generally the value for the rough one is a bit higher than the second couple. So the rough titration is number 1 in this case here. Okay. Right, part B. What volume of acid would be used in the calculation to find the concentration of sodium hydroxide? Now, what you need to remember, and again, hopefully you remember this from doing the experiment, when you are working out the volume that you need to use in your calculations, you need to do an average of the concordant results. So concordant results are results that are within concordant results are within 0.02 centimetres cubed of each other. Okay, so 26.8 and 27.0 are are exactly 0.02 centimetres cubed apart, so we would describe them as concordant results. So sometimes you get asked the definition of concordant results, and you would say concordant results are results which are within 0.02 centimetres cubed, you could say, of each other. And so when we're doing the average volume for a titration calculation, we take the average of concordant results. So we do 26.8 plus 27.0, and we would divide that by 2 because we're taking an average of these 2 numbers, and there are 2 numbers. So 26.8 plus 27, and the average works out at 26.9. And then finally, using the volume from part B, we have to calculate the concentration of sodium hydroxide in the bottle. So what we need for that is we need a balanced equation. Now, on this copy of the sheet that I've got here, I've just realised that I haven't actually given you a balanced equation, but I will put a balanced equation into the final one. So I'm going to do this question on a little separate piece of paper here, and hopefully you'll be able to see everything that all the information you need and be able to follow what I'm doing here. So this is similar to your calculations from balanced equations using masses, because it's essentially the same 3 steps. You need to work out which substances in the equation it's talking about. You need to calculate the number of moles for the one you've got most information for. You need to use the mole ratio, and then you need to work back to calculate something about the other substance in the equation. So let's write a balanced equation for this. So we've got sodium hydroxide reacting with sulfuric acid. Okay, and you should know that should make the salt sodium sulfate plus water. We're going to have to balance this equation, so we are going to need 2 sodium hydroxides for every 1 sulfuric acid, and I think we'll also then make 1, 2, 3, 4. 1, 2, 3, 4. So we're also going to make 2 molecules of water in that equation. So that's our balanced equation. And we are given information about the sulfuric acid. We're told the concentration and the volume of the sulfuric acid that we're using. And we are also told information about the sodium hydroxide, and we're asked to calculate the concentration of sodium hydroxide. To be honest, in titrations, we're almost always just looking at the 2 reactants. So just like before, we're going to do a data column for each of the substances in the equation that we're interested in, so that we can calculate moles, because again, in titration calculations, we're going to work through moles. We're going to use the mole ratio to work out our the quantities that we need to. So we're going to do data columns for NaOH, and we're going to do a data column for H2SO4, sulfuric acid, sodium hydroxide. So we're going to always need to work out the number of moles, but we don't have that information for either substance yet. Now, the information that we're given then, sodium hydroxide, well, in this part of the question it says each time 25 centimetres cubed samples of the sodium hydroxide were pipetted. Okay, so 25 centimetres cubed, that is a volume. Okay, and we are asked to calculate the concentration of sodium hydroxide in the bottle. Okay, the sulfuric acid, we are told that the volume is the one that we should use is the volume from part B. So that is 26.9 centimetres cubed. And the concentration that we use is going to be 0.1 mole per litre. Okay, because that tells us the concentration there. Okay, so remember when we see MOL space L to the power of -1, that's moles per litre, that's the concentration, that's not the number of moles. Okay, so again, just like in the previous example, our 3 steps are pretty similar. We're going to calculate, first of all, the number of moles of the substance we have most information for. Okay, so we've got most information about the sulfuric acid, so we're going to calculate the number of moles for that. Now I'm given a concentration and a volume, so the equation I'm going to use is N equals CV. N is on its own, and N equals C times V in the data book. So C and V must go on the bottom in this little triangle. So for calculating moles, I don't need to rearrange the equation. N equals CV, which is 0.1. Now, the one thing I do need to remember, though, is to convert this volume into litres. So divide by 1,000, and that's going to be 0.0269 litres. Okay. So I'm going to do 0.1 times 0.0269. Notice how, because I've divided this by 1,000, I can just press times 0.1 in my calculator. I don't need to retype that, so I'm going to get 2.69 times 10 to the power of -3 moles of sulfuric acid. Okay, so our step 1 was calculating the number of moles. Our step 2, remember from before, is using the mole ratio. So the mole ratio is for sodium hydroxide to sulfuric acid, and it's a 2:1 ratio. So that means if I have 2.69 times 10 to the minus 3 moles of sulfuric acid. Just need to think, well, what do I need to do to get from here to here? So to get from here to here, from 1 to 2, I need to times by 2. So for this one here, I need to times it by 2. Again, I've left it in my calculator, so I just need to press times 2. It makes it a bit quicker. And then I've got 5.38 times 10 to the minus 3 moles. So remember, by laying it out in this way, by writing out the formula for each substance above the mole ratio, it keeps it nice and clear what the moles are, what substance each of these numbers relates to. So 5.38 times 10 to the minus 3, that's your number of moles of sodium hydroxide. So I now no longer don't know this, I do know it, and I can write in 5.38 times 10 to the minus 3 moles of sodium hydroxide. Again, my volume's in centimetres cubed. I need to divide that by 1,000. So I'm going to do 25 divided by 1,000, and that's going to be 0.025 litres. So my final step in this calculation, it was calculate mass in the previous example, but this time my final step is going to be to calculate the concentration of the substance that I now have enough information about. So concentration, if I cover up concentration here, concentration is number of moles divided by volume. Okay, so that's going to be 5.38 times 10 to the minus 3 divided by 0.025. I will have to retype that into my calculator now. So 5.38 to the minus 3 divided by 0.025. And that equals 0.2152. Now, what I tend to do if I was doing this in an exam would be write out the whole number and then round it underneath, or at least write out a few decimal places. So 0.2152, I'm going to round that to 2 decimal places. So 215 would round to 0.22. And my concentration, remember, it's measured in moles per litre. And I would just double underline my final answer. Now, if I was doing this in a test, what I would actually do is also just double check my calculator work just to check I hadn't made any mistakes. Okay, so I would be just going through all of that again in my calculator just to make sure, if I had time, that I hadn't made any silly mistakes there. Hope this helps. So now what you need to do is you need to go to the 2019 past paper and do question 5C part 1 and question 12B to practice some of these balanced equation calculations.